Very single day, 800 million vehicles burn through 7 billion liters of fuel. Gas stations across the world never run empty of this highly flammable liquid that powers our civilization. But here's what most people never think about. That clear, volatile fuel sitting in your tank started as something completely different. Something black, sticky, and smelling like rotten eggs, buried thousands of meters beneath the earth. The transformation from crude oil to gasoline is one of the most complex industrial processes on the planet. And it's happening right now in massive facilities that operate like clockwork, 24 hours a day, turning ancient organic matter into the lifeblood of modern society. Today, we're taking you inside the American oil industry in Texas, one of the most powerful industrial regions on Earth. You'll see how crude oil is violently ripped from deep underground using massive drilling operations that never stop. Then we'll follow that black gold as it travels over 1,000 kilometers through pipelines to reach the largest oil refinery in the United States. There, you'll witness the incredible process that transforms crude oil into gasoline through extreme heat, pressure, and precision chemistry. By the end, you'll understand exactly how that fuel in your tank went from prehistoric organic matter to the refined product that powers your car. Here's something that will change how you think about gasoline forever. The oil being extracted in Texas today isn't just from a few years ago, or even a few decades ago. The crude oil they're pulling from the ground right now was formed 250 million years ago, when tiny marine creatures and plants died and settled on ancient ocean floors. Over millions of years, heat and pressure transformed this organic matter into the black gold we call petroleum. What you're putting in your gas tank is literally the compressed remains of life from an era when dinosaurs ruled the earth. That's the raw material for every drop of gasoline ever produced. The journey from ancient organic matter to modern fuel begins in the oil fields of Texas, where drilling operations have been running since 1894. But it wasn't until 1901 that the industry truly exploded into what we see today. Since then, American companies have extracted almost 60 billion barrels of oil from Texas soil alone. The scale is staggering, and according to petroleum companies' calculations, there are still around 10 billion barrels waiting to be extracted. This isn't just about fuel for cars. Petroleum provides 50% of the energy we need, and petrochemical derivatives become the basic components for most products we use daily, from plastics and asphalt to tires, cosmetics, and pharmaceuticals. Finding oil is essentially an expensive gamble, even with modern seismic technology helping identify potential underground deposits of oil and natural gas. Oil exploration remains a high-stakes bet. Companies can spend millions drilling a well that produces nothing. The drilling teams work in scorching heat and deafening noise, operating massive engines that drive diamond-tipped drill bits deep into the earth. But here's the first critical challenge. The friction from drilling generates enormous amounts of heat that can destroy the cutting head. To prevent this, they must constantly pump pressurized water down the hole, which brings the drilling debris back to the surface as thick mud. If the pressure isn't exactly right, everything fails. Too little pressure and the bit can't cut through rock. Too much pressure and the drill bit shatters completely, destroying hours of progress and costing tens of thousands of dollars. The drilling operation runs 24 hours a day, and every 2 hours, the crew must add new sections of drilling pipe using a massive 5-ton automatic wrench. The drill bit advances at just 5 meters per hour through rock that's 542 million years old, trying to reach oil deposits that can be buried up to 4,000 meters deep. Each month, over 2,000 new wells are drilled in Texas alone, and together, they extract more than 900,000 barrels of crude oil per day. Companies like Occidental Petroleum drill an average of 1 new well every single day. But there's another deadly risk that can end everything instantly. Gas emissions during drilling can cause catastrophic explosions. The drilling crew must constantly monitor pressure levels and gas readings, because one mistake doesn't just mean lost time or money, it can mean lost lives. When they finally strike oil, something incredible happens. The initial pressure from the trapped petroleum is so intense that it forces the oil up through the drilling pipe and shoots it to the surface on its own. This is the moment when months of dangerous, expensive work either pays off spectacularly or fails completely. The black, sticky liquid that emerges smells like rotten eggs, but represents liquid gold. This is crude oil in its raw form, the premium material for gasoline production. But that natural pressure doesn't last forever. Once it's gone, they install massive pump jacks that work like enormous syringes, using circular motion converted to vertical movement to continuously suck oil from deep underground. These pumps operate day and night, extracting every possible drop from each well through a network of pipes that feed into main lines. The fluid that comes up isn't pure oil. It contains carbon dioxide, hydrogen sulfide, and natural gas that must be separated immediately. Each well's output flows through pipes into a main collection line, but the real challenge is just beginning. These Texas oil fields are located far from where the crude oil needs to be processed, so a series of powerful pumps inject the oil into pipelines for a 1,000-kilometer journey to the refinery. During this journey, the oil must maintain specific pressure and temperature ranges, or the entire system can fail. Pipeline monitoring stations check for leaks, pressure drops, and contamination every few kilometers. A single rupture in the pipeline means not just environmental disaster, but also the loss of millions of dollars worth of crude oil. The monitoring systems track thousands of data points in real time, because crude oil is corrosive and can eat through metal pipes if not properly treated. Temperature fluctuations can cause the oil to expand or contract, potentially bursting pipes or creating dangerous pressure buildups. Every pump station along the route must maintain precise pressure levels to keep the oil moving, and if any station fails, the entire pipeline system can shut down, affecting fuel supplies across multiple states. The crude oil finally reaches its destination, the largest oil refinery in the United States. This massive facility spans 10 square kilometers and contains over 8,000 kilometers of metal piping. It can process more than 562,000 barrels of crude oil per day. But here's where everything becomes incredibly dangerous. The noise inside the refinery is so deafening that the 4,000 workers use over 1 million ear protectors per year. One small mistake in this facility could trigger explosions that would be visible from space. The crude oil arrives as a complex mixture of hydrocarbons, each with different numbers of carbon atoms and different weights. The lightest is propane, while the heaviest is used to make asphalt. But before any processing can begin, they must remove the deadly hydrogen sulfide gas that could poison workers and cause catastrophic reactions. The transformation begins with extreme heat. The crude oil is heated to over 370 degrees Celsius and pumped into the base of massive distillation towers that rise like industrial cathedrals. As the oil turns to vapor and rises through the tower, something extraordinary happens. The different components separate naturally as they cool at different heights. The heaviest molecules, like asphalt, condense first and sink to the bottom. Lighter molecules, like gasoline and kerosene, continue rising until they also condense and can be extracted through carefully positioned siphons at different levels of the tower. This process runs continuously, 24 hours a day, with each tower processing thousands of barrels per hour. From every 191 barrels of crude oil, they extract 88 liters of gasoline, 48 liters of diesel, 26 liters of kerosene, almost 7 liters of propane, and 32 liters of other products like lubricants and plastics. The precision required is incredible. Temperature variations of just a few degrees can ruin entire batches, and pressure changes can cause dangerous backflows that could destroy the equipment. But producing gasoline isn't enough. The fuel must pass rigorous quality tests using specialized engines that check its detonation capacity. Detonation inside an engine happens when fuel ignites spontaneously, under compression in the cylinder, which can destroy an engine instantly. Laboratory technicians run continuous tests, and any batch that fails specifications must be reprocessed or discarded entirely. The laboratory can send data back to the refinery to correct errors in the mixture and ensure perfect quality. Here's the terrifying part. A defective batch of gasoline could make it through testing and reach gas stations, potentially damaging thousands of vehicles before the problem is discovered. Quality control teams hunt for microscopic impurities and chemical imbalances that could cause engine knock, reduced performance, or even complete engine failure. When the gasoline finally passes all quality tests, massive valves open and the fuel flows through underground pipelines to distribution terminals. From there, it's loaded into enormous tanker trucks. But this loading process is more dangerous than filling your car's gas tank. A single mistake during loading or unloading could end in a devastating explosion. The metal truck body can generate sparks from static electricity, so the first step is always connecting a grounding cable and activating sensors to prevent overfilling. A second pipe called the vapor recovery line absorbs the fumes released during loading to prevent them from dispersing into the atmosphere. Every day, approximately 4 million liters of gasoline are transported to gas stations across the country. After the gasoline is unloaded into large underground storage tanks at gas stations, it's finally ready for consumption. The next time you fill up your tank and think about how expensive fuel has become, remember the incredible journey that gasoline has taken. From organic matter that died 250 million years ago, through dangerous drilling operations that never stop, across thousands of kilometers of pipelines, through extreme heat and pressure in massive refineries, and finally into your tank. But here's what's really unsettling. This entire system depends on oil reserves that took millions of years to form, but are being consumed at an unprecedented rate. The same industrial processes that power our civilization are also racing against the clock of geological time itself. Every drop of gasoline represents millions of years of natural processes compressed into a fuel that burns in seconds. If you found this journey as fascinating as we did, hit that like button and subscribe for more secrets from the world's most powerful industries. And let us know in the comments, what other industrial processes would you like to see exposed? The machinery of modern life has more secrets than you might imagine.